Throughout millions of years since the Earth's formation, constant heaving, buckling, and erosion have changed many portions of the Earth's surface. Many areas were repeatedly covered by shallow seas. Countless billions of tiny organisms died and settled to the bottom, where they became buried under sand and silt. There, it is believed, the entombed organisms were transformed into oil. Accumulated pressures of gases, water, and earth sometimes drove the oil through the porous sand and sedimentary rock. And often, it migrated to underground reservoirs sealed by non-porous formations where the oil was trapped. It is from these reservoirs that oil is now most likely to be recovered in commercial quantities. Thus, today, the oil geologist searches both for locations where oil may have been formed and locations where oil may have been trapped. Conditions that were favorable to the formation of oil may be indicated by traces of ancient seas and fossilized remains of long extinct organic material. Underground formations where oil may have been trapped may be indicated by surface structures. Stereoscopic photographs are a great aid in the study of surface indications. Another method of search for oil is through chemical analysis of soil samples for minute evidence of seepage of the lightest hydrocarbons. The economy of this method permits blanketing large areas, and promising indications are then verified by more expensive detailed geophysical methods. In the far-flung search for oil, modern geologists and geophysicists often make use of the helicopter and the marsh buggy, a special vehicle which can take them into almost inaccessible swampland. Subterranean oil traps may be found by mapping underground formations. The gravity meter gives clues to the nature and depth of these formations by measuring the gravitational pull. The magnetometer is another instrument that can help plot underground formations by measurement of the Earth's magnetic fields. One of the most important of all methods of search is the seismograph. A shallow hole is drilled for a small explosive charge, and special microphones are strategically placed around the shot. The detectors will pick up the explosion and the shock waves reflected from far underground. This will give information as to the shape and depth of the underground strata. The shock waves are reflected by the various rock layers underground and are recorded at the surface. The time it takes for the waves to make this round trip varies with the distance they travel. The recorded measurement of this time lapse indicates the depth. Thus, through a series of shots, the shape and depth of underground formations are mapped with accuracy. The seismograph is even used to detect potential drilling sites several miles out at sea. Special sensitive geophones are lowered into the water to predetermine depths and positions. Explosives are detonated under the water. As on the land, the recordings of reflected shock waves reveal variations in the ground strata under the seabed.